And then I'll upload this, and then we'll have a good lesson on a good video. Okay, so this is lesson 3.5, graphing transformations. So let's just go ahead. I was going to try to guess if this is going to be on your midterm or final, but truly I can't even really remember. Okay, so these right here are all called parent graphs. Okay, let's write those down. Parent graphs. So parent graphs are just the regular normal graph, and then you start changing it, like right, left, up, down, reflect it, stretching it, shrinking it, that kind of stuff. So for a parabola, your vertex is always at 0, 0. And then the stretch is right 1, up 1, left 1, up 1. And then right 2, up 4, left 2, up 4. Okay, so that is your parent graph. Now, I want you to write down f of x equals ax squared. A being the number in front of the x squared. So if a is not 1, if it was like 2x squared or 1/3 x squared, then that's either a stretch or a shrink. And here's how you deal with it. It's so easy, you guys. Look, you still take those same steps, 1, 1, 2, 4, but the difference is you take the up movement and you multiply it by whatever this value of a is. So right here would be 1 comma, and then up would be 1 times a, which is just an a, and then the other one is 2, 4, but you times it by a, so it would be 2 comma 4a. Easy. You have to have that graph memorized. I'm sure you all do. Okay, here's square root. Parent graph. Right at the origin. Right 1, up 1. So I want you to draw this step 1, 1. The next one is 4, 2. So draw the step 4, 2. Draw it in. There's your graph. Okay. Underneath, I want you to write f of x equals a times the square root of x. What if a is not equal to 1? What if there was a number there, like a 3 or a -5? How do you deal with it? Well, you still take the same steps, but you multiply those ups by a. It's the same thing. So 1 times a is an a, 2 times a is a 2a. So that's how you deal with that stretch or that shrink. Okay? Let's do a cubed. Those two that I just did are the most common. These other guys are just kind of, maybe, but the chance is pretty low. Okay, a cubic, you have a pencil at the your center's right at the origin, and then you go right 1, up 1, and you balance that with left 1, down 1. And then the next step would be 2. Can anybody, can anybody tell me how far to go up on that one? It's easy to figure out, right? Because the right and left is the x. So if x is 2, 2 to the third is 8. So it'd be like that. So you go right 2, up 8, left 2, down 8, and it's just this super steep graph. Okay, underneath, write down f of x equals a x to the third. Duplicate the 1, 1, 2, 8. If a is not 1, you multiply the ups by a. So 1 times a is a, 8 times a is 8a. Okay, this guy right here, cube root. Pencil at the origin. Then the next one is 1, 1. Why is it 1, 1? Because the cube root of 1 is 1. Put your pencil back at the origin. Oh, you have to match it on the other side. Does anybody know how far we have to go right from the origin before I can go up 2? It is 8. The cube root of 8 is a 2. So everybody go to the right 8, up 2. Left 8, down 2. There's your cubic. Looks like that. Okay, so we did 1, 1, and then we did 8, 2. underneath that, write down f of x equals a times the cube root of x. If a is not 1, then you go 1a, 8, 2a. That's it. Okay, last one is an absolute value. So an absolute value, you have your pencil at the origin again. These are all start at the origin. And then it's just right one up one, left one up one, then it's repeat. Right one up one, right one up one, right one up one, right one up one, left one up one, left one up one, left one up one. Looks like that. So for my explanation, I'm going to say 1, 1, repeat. You could go 2, 2, 3, 3. I just do 1, 1, repeat. Underneath, write down f of x equals a times the absolute value of x. If a is not 1, then you go 1, comma, a, and repeat. Okay? Who says I understand this? I'm with you. I'm totally good. Okay, so unfortunately, I'm going to teach you this whole lesson using one method. You're going to be awesome. You're going to be great. Everything's good. Then at the very end, I have to introduce a second method. The reason I have to do that, and I know that's tough, but the reason I have to do that is because they ask these questions in two different ways. And one way, this method is so easy. And the other way, the other method is so easy. But to use the wrong method it's tougher. So that's why I teach two methods right here. And I know that's tough, but I think you'll be fine. Okay, right here, everybody draw an arrow to that D. If there's something outside of the function, okay, look right here for 2 seconds so I make sure you understand outside the function. Here's your function. Anything over here in front of it or behind it is outside of the function, okay? So the 1 is outside. It's not within the x squared. So if that's outside of the function, then that number moves your graph. You guys tell me where or where? Up or down. So everybody write up or down. Now, this is what I expect of you when you do these problems. The first thing I always expect you to graph is your parent graph. The second thing I always expect you to do is to reflect. You must reflect right after the parent if it has a reflection. And then step number 3 is everything else. That's a lie. Stretch or shrink. And then step number 4 is everything else. Okay, so let's do question 1. It's so easy. It's just, it's silly. Okay, first thing I always want you to do is to start with the parent. So 0, 0, 1, 1, 2, 4, draw it in, super easy. Okay, everybody in the room, tell me what that plus 1 does to my graph. Up 1, okay? So let's literally write up 1, and then let's take that guy and move it up 1, right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4, graph it in, done. Piece of cake. Start with the parent. Always start with the parent and then adjust the parent, okay? Okay, here goes question B. Absolute value. Here's my parent. If you complain about drawing the parent, you'll complain longer than it takes you to draw it. So you may as well just do it. Okay, there's your parent. Everybody in the room, tell me what the negative 3 does to my parent. Down 3. So simple. Move it down 3. Right 1 up 1, left 1 up 1. Left 1 up 1, left 1 up 1, repeat. There you go, done. Okay. Look right here, guys. Do you see how this C is within? Do you see on this example? Do you see how the X is inside? It's within the squared. That's inside. The green is outside. Raise your hand if you say, I see that the 2 is inside. I can tell the difference between in and out. Okay, good. So if it's in, it affects the x, but the x lies. I want you to remember the phrase, the x lies. If it's with the x, it's the opposite of what you think. So that is either going to move your graph right or left. If the middle sign is a plus, you would think right. It's actually the opposite. If the middle sign is a plus, you go left. If the middle sign is a negative, you go right. The x lies, so just remember you always do the opposite, okay? Right here, everybody write down y equals x to the second. That's my parent graph. I'm always going to start by graphing the parent. So pencil at the origin, right one up one, left one up one, right 2 up 4, left 2 up 4. There's your graph. Looks like that. Everybody tell me, what does that minus 2 do to your graph, everybody? Moves it to the right 2. Okay, so now I'm just going to take that vertex, move it to the right. You could do this. Watch this right here for 2 seconds. See this 1, 1? You could find the same point here and go right 2. This 1, negative 1, go right 2. I would never do that. I know the stretch so easily. So you just find that new vertex, right 1 up 1, right 2 up 4. That's a way faster way to do it. Done. Okay, who says gotcha? Raise your hand, let me see. Okay, great. Okay, this one right here, when they ask you for domain, range, intercepts, all that, that is from the final graph. It's not from the parent, it's not from the first transformation, it's from the final answer to the graph. Okay, so your parent is a parabola. So just very quickly draw in that parent graph. Okay, and now what I want you to do is over on the side, I want you to list the transformations. So guys, we have a -3 and we have a -1. Someone tell me, or everybody tell me, what does the -3 do to your graph? Down 3. And I want you to write that down. What does the -1 do to your graph? Moves it to the right 1. Okay, let me show you how I would do this. I'd find my vertex, which is at 0, 0, over here. I'd go down 3, right 1. There's my new vertex. Then I would duplicate the stretch. Right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4. Graph it in. There's your graph. Done. Okay. Okay, look at the graph. It's this guy right here. Everybody in the room, tell me the domain. Everything. Left to right, everything touches it. Range is y, start low. What's the first y that's going to touch it, everybody? -3. And does it actually touch it? It does. So it's going to be a -3 with a, tell me, a bracket to infinity. The domain, I'm just going to put all real numbers. X-intercept. Okay, now this is kind of tough because the x-intercept is not a good number. So I'm going to skip it for just a second. I'm going to go to y-intercept. The y-intercept is clean. It's when x is 0, and that is 0, -2. Now let's do x-intercept. So the x-intercept is found by letting y be a 0. So I'm going to go into the given equation right here, and I'm going to let y be a 0. So everybody write down x minus 1 squared minus 3 equals 0. Looks like that. You tell me, shout out, what's the first step? Move your 3, right? So you have x minus 1 squared equals 3. Tell me what to do now. Square root. So you have x minus 1 equals, tell me what comes right here. Plus or minus. Why plus or minus? The easiest response I've got is because you did the square root. The square root wasn't there. If you're the one that does it, you must add the plus or minus. Okay? So it's plus or minus the square root of 3. Pull the 1 over. 1 plus or minus the square root of 3. Now, what I would not write an ordered pair with a plus or minus. So I would go 1 plus the square root of 3, 0, and then I would go 1 minus the square root of 3, 0, and that's it. Okay? That's it. Okay, let's do this one. People get a little confused about this, so I want you to watch closely, okay? I want you to write, well, if you have a negative, it's a reflection. Sometimes it's a reflection across the x-axis, sometimes it's a reflection across the y-axis. You have to remember which is which. If you alphabetize x and y, what comes first? X. X comes first, then comes y. So if the negative comes first, it's a reflection across the x. If the negative does not come first, it's a reflection across the y. Easy to remember. If you see that negative right in front of the function, that's x. If it's within the function, that's a y. Who says I understand? Let's see. Okay. See right here? First, alphabetize, first is x. Not first. It's not there. It's the parenthesis comes first. It's within. That's y. Okay? Yes.
So if there's parentheses, it will always be y.
Yes. Well, let's just say yes for now, because it'll get more complicated later. But for now, we'll say yes. That's a great way to say it, actually. Yes. For now. Okay. Let's do the parent. Square root 0, 0, 1, 1, 4, 2. Draw it in. That's your parent. You tell me. This is a reflection. Is it across the x, everybody, or is it across the y? It's across the x. How do you know it's x? Because it comes at the front. First, x. Okay? So see that graph right there? Wet paint. Here's your x-axis right here. Fold it across the x-axis. It's going to come down like that. I'm going to graph it on this new grid though. So here, write 1, down 1, write 4, down 2, graph it, done. Okay, this guy right here. Parent graph, pencil at the origin, write 1 up 1, write 4 up 2, graph it. I've got a negative. Negatives always mean to reflect. The negative is not first. First is x. So it's not x, it's y. So this is a reflection across the y axis. Who says I can tell the difference between x and y? Give me feedback because I'm feeling nervous. Okay, good. So here's your y-axis. Here's your wet paint. Fold it across and it's coming to the other side. So it's right here. Left 1 up 1. Left 4 up 2. There's your graph. Looks like that. Okay. Okay, now we're going to have stretches. We already addressed this when we started the lesson and we had the little steps, right? So, parent graph, pencil at the origin, right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4, draw it in, looks like that. Okay, now, watch guys, normal step, 1, 1, 2, 4. But I have a vertical, is this a stretch or is that a shrink? It's a stretch. Everybody write this down. Y equals ax to the second. If the absolute value of a is greater than 1, then it's a stretch. If the absolute value of a is less than 1, then it's a shrink. Why do I even have to bring the absolute value into the discussion? Why is that even a thing? Absolute value just says ignore the sign. The sign is a reflection. It's just the numerical value, okay? So this right here is a stretch because 3 is bigger than 1, okay? So instead of 1, 1, 2, 4, guys, look what I'm going to do. I'm going to go 1, 3, 1 times 3 is 3, 4 times 3 is 12. I'm sure you guys understand this already, but will you look right here for 2 seconds? Here's a normal parabola, and if I stretch it, I stretch my arms up. That's a stretch. That's what a stretch. It just makes it go skinny. Okay? Okay, so pencil at the origin, 0, 0. Right one up 3, left one up 3. You guys, the next one is 212, which is off the grid. So just be really careful, okay? This is not right. Someone tell me what's wrong with that graph. It already hit the 2. You're a rock star today, April, just so you know. You got every answer, girl. I love it. It already hits the 2. And it's not supposed to hit the 2 until when? All the way up to a 12. So this guy right here is way too wide. I'm not supposed to hit that x value of 2 for a really long time. So that stuff is not supposed to be like that. It's supposed to be super steep and not hit that x value of 2. Okay, done. Okay, right here, this is a shrink. Okay, let's draw the parent. 0, 0, 1, 1, 4, 2. Draw it in. And this is a shrink. Watch how easy, guys. You just take that step, 1, 1, 4, 2, and you change your up movements. You just take those up movements and multiply them by a half. So 1 times 1/2 is 1/2. 2 times 1/2 is a 1. So that's really supposed to be a 1. That's all I do. So pencil at the origin, right 1 up a half, right 4 up 1. A shrink makes it wider. Okay, do me a favor and look right here. Here's a parabola. This is a stretch. I'm stretching. This is a shrink, right? If you're shrinking down in your seat, you're kind of like this. That's what it does. It just makes it wider, okay? All right, here we go. Now we're going to have lots of different transformations at once. So the video, anybody that watched the video already, you're so lucky with how we get to do this. Weber State, before it changed who managed the concurrent enrollment, they used to make us draw the parent, write the equation. Do one transformation, write that equation. Do another transformation. So sometimes you'd have like 5 graphs until you get to your final graph. And I don't do anything like that. So don't complain, I guess is what I'm saying, that you have to do multiple graphs, because it's been so much worse in the past, okay? Okay, so the first thing I always want you to do, number 1, always parent, okay? And that's super easy. It's just an absolute value graph. Looks like that. It's just a V. Okay. The second step is always, this is super important. It's actually the number 1 reason people miss these problems. The second step must be blank if you have it. What is it? What am I saying? What's the blank? We said it about 15 minutes ago. Yeah, it's okay to look back. So I said the first thing I want you to do is parent. The number 2 was what I say? Reflection. Do we have a reflection on this problem? Yes or no? Yes. We must reflect. And that is the only thing, R-E-F-L-E-C-T. That is the only thing I want you to do. Now you tell me, is this an x-axis reflection, everyone, or a y? It's an x, because the negative comes at the beginning, okay? So you're just going to take that absolute value, and you're just going to open it down like that, okay? Now let's list all the other transformations. So the -1 takes your graph and shifts it where, everybody? Right 1. And the 2 stretches it. So instead of 1, 1, it's going to be 1, tell me everybody, 1, 2, like that, okay? So take that vertex right there, move it to the right one. It still opens down because that first is a negative, but instead of 1, 1, it's going to be 1, 2, and then you just keep going, 1, 2. Do it a couple of times, draw it in, there's your graph. Okay? All right, this is a summary, and it looks like we're almost done, doesn't it? Well, maybe not. You guys are like, no, it doesn't. This is like the eternal lesson. So we're done with that method. Now we're doing method number 2. Okay. Why do I have to show you 2? Because it's confusing. It's because of the way they ask the question. Long story short. Okay. Okay, so watch this closely because it's super important. Remember that the x lies. Okay. So look right here. You guys tell me. I want you to highlight this. If it's on the inside, it affects the x. If it's on the outside, write this down somewhere. If it's on the outside, it affects the y. You tell me. See this 3? Is it on the inside or is it on the outside? Tell me. It's on the inside. Is there anything outside of that f of x minus 3? Nothing. So the y is not changing. So my y is going to stay a y. My x is going to change. But the x lies. So that says x minus 3. What's the opposite of that? That would be x plus 3. So it's the opposite. This is method number 2. So do you see this ordered pair right here, guys? 4, -1. You just changed that ordered pair. Well, the y is not going to change. We just talked about that. The x, you're just going to add 3. 4 plus 3 is 7. That's your answer. That's all you have to do. Okay, let's do another one. This is tricky, so I want you to watch. Is the 3 right here on the inside or the outside? Everybody tell me. It's on the inside because it's within the f of x notation. You tell me, is there anything on the outside at all? Do you see anything out there? No. So the y, she thought I said Siri. So the y is just going to stay a y. Okay. The x lies. So in the equation, it's multiplied by 3. So over here, you're going to take your x and you tell me. You divide by 3. Do the opposite. Okay. So take that beginning point, 4, -1, and change it. So the y does not change. The x, you write it down, you divide by 3, and there it is. Okay. Okay, let's do this one. First example. Right here. Is there anything within on the inside of my f of x? No. There's no change to my x. The negative and the 2 are both outside. Those affect the y. Watch how sweet this turns out. Watch right here. If you take this f of x and you just rewrite it as a y, that's the formula for the y. So it would be -y plus 2. So you're going to take that ordered pair, which they gave me was -2, 3. The x does not change. You guys, when you put that 3 in for the y, you get, do you multiply the 3 by a negative and then add 2? Or do you take 3 and add 2 and then multiply by the negative? What do you do first? Do you multiply first or do you add first? Why? You're correct. Why is it multiply? One quick, easy answer. Order of operations. Multiply before you add. So that's going to be a -3 plus 2, which is a -1, and that would be my point. Who says I understand what you're saying to me? Okay, great. Okay, right here. You guys talk to me because I feel a little worried, okay? I think I feel worried because I only have half of you watching me, and so only half of you are responding, but that makes me think only half of you understand. Are there any changes to the x? Tell me that. Look at the yellow. No change. Nothing there. So x stays an x. Watch how easy. See this f of x? Make it a y. That's the formula for the y. 2y minus 4. Take that ordered pair. Don't change the x. Stick in a 3. So when you stick in a 3, you're doing this. What do you have to do first? Obviously, you have to multiply first, right? 3 times 2 is 6. 6 minus 4 is a 2. There's my answer. Done. Okay? This is why we learned the second method. Do you really want to go down 2, left 3, reflect across the x-axis if you don't even know what that parent graph looks like? They didn't even tell you what the parent graph looks like. Okay, so this is why method 2 is essential. Okay, look right here. Changes to the x. X becomes, it is not x plus 2. What is it, everybody? X minus 2. You've got to remember the phrase x lies. Now, y becomes, everybody watch this because we haven't had an adjustment to the x and y at the same time when we did this. Look right here. See that whole green thing right here? F of x plus 2, just scribble it out, replace it with a y. That's your y formula, negative y minus 3. So easy. Okay, now let's take that point and let's change it. So 2 minus 2, that's a 0. The x is minus a negative 4, that's a plus 4. 4 minus 3 is a 1, and I'm done. Okay, who says I understand? Okay, now, this gets a little crazy. Where are we at with time? Somebody tell me how much time we have left. Oh, we have 30 minutes, right? Fine. We're fine, we're fine, we're fine. Okay, here's what we're doing now. And this is what it's going to look like when you have to do it on the big guy. This is what it's going to look like. I think I told everybody this, but I'm going to tell you again. I went through your workbook already, and I have highlighted what was on the midterm and the final last semester. So if we have time on Friday or Monday, whenever I see you, I'm going to give you that information. So you can, as we go through the lesson, you're like, oh, this is important because it was on there last semester. Or this one's not too important because it wasn't there. So I need to understand, but I don't need to freak out, okay? Okay, everybody listen and watch. Okay, I'm going to go slowly. This is not a typical parent graph. You've got this graph and you've got these points, but it's not like a typical parabola or square root. And that's kind of why it gets a little tricky. Okay, who says I understand what you're saying to me? Okay, I want you to change the graph just a little. And I actually, these notes, I've just recently edited like the last couple of semesters. I don't love this graph. And there's one little reason I don't love the graph. Do you see this point right here? How it's not a turning point? I want you to change your graph just a little bit. And I actually want it to be a turning point. And it's going to make the whole problem so much more understandable if it doesn't peak up after that. Let's make that a peak, okay? Okay, I want to talk to you for just a second about end behavior, okay? Everybody write down end behavior. Okay. Don't write this down, just watch. If you have a parabola that opens up, just watch. The end behavior is not the middle stuff. It's the end. As x gets big and as x gets small, what's my end behavior? Look right here for a second. For a parabola, the end behavior is this, up, up. Who says I understand that? Okay, so for a parabola, you don't have to write this down, just kind of listen, up, up. For a cubic, like that, I don't know why my cubic looks weird. Don't care about the middle, it's the end. Left down, right up. Who says I understand that? Okay, now let's talk about the end behavior of this graph. So of this graph right here, the end behavior is going to be my left side goes down and my right side goes up. Who says, I get that? I'm totally with you, 100%. Okay. So I want you to write no reflection, same as original. So it would still be this for this specific graph, left down, right up. Okay. What if you have an x-axis reflection? Okay, I think the best thing to do right now is for you to just watch. Okay, look. Here's my x-axis. What I care about is this and this, because that's my end. So if I fold those over the x-axis, this yellow goes down and this yellow goes up. So it changes my end behavior. So if I have an x-axis reflection, my end behavior is actually going to be left up and right down. Who says I understand that? Let me see. Okay. It's the end behavior is critical. You have got to understand it. Okay. What if you have a y-axis reflection? Okay. What I want you to do is to just watch. Look. Here's your y-axis. All I care about is this and this. This guy here on the top, where's he coming? Over here. This yellow guy down here, when I fold him, where's he going? Down there. So what's my end behavior? Left up and right down. Okay, who says gotcha? Okay, so whether it's an X or a Y, it doesn't matter, it changes. Okay, so let's just hook those together and say changes. No reflection, no change. Okay? Okay, everybody, look at this. Step number one, I want you to go X becomes and Y becomes. And I want you to put a star right there. So what happened last semester is my students didn't write that down. And then they messed up, and then I couldn't give them any partial credit. Nothing. Because I didn't even know what they were doing. And they had messed up. But had they written it down, I would have been like, oh, this is what they're doing. So I can give them a little bit here. If you don't write it, it's over. Okay? So everybody write X becomes and Y becomes. So whatever happens to the X is here. The X lies. So I'm going to take my X, and instead of multiplying by a -1, I'm going to divide by a -1. Anything on the outside, which is in the yellow, affects the Y, but the Y tells the truth. So Y becomes Y plus 1. Who says I'm with you? Let me see. You guys, is there any difference between multiplying by a -1 and dividing by a -1? Is there any difference in the result? If I have 5 and I times it by a -1, I get -5. If I have a 5 and I divide it by a -1, I get -5. So is there any difference? No. So you can go ahead and totally write it like that. I don't write it like that. I understand that I'm dividing by a -1, which just tells me to change the sign. It's the same thing. Okay, you do it however you want. Okay, see those 3 points right there on the parent graph? I want you to write those down. So everybody go -1, 0, and I want you to put an A in front of it. And then B is 0, 2, and C is 3, 0. Out in front of the B, I want you to put a T, and in front of the C, I want you to put a T. Because those are turning points. -1, 0, the graph is not turning there. But once I hit the 0, 2, it turns. And once I hit the 3, 0, it turns. Okay, who says I'm with you? I understand. Okay, so step number 2 is right here. Write down the points and change the points. Okay, so you're going to go like this, guys. Look, you're going to do an arrow. And you're going to call this A prime, B prime, and C prime. It's just another name for the next A. So take your X's and change the sign. So the negative 1 goes to a positive 1. The 0 stays a 0. The 3 becomes a negative 3. Take the y's and add 1. 0 plus 1 is 1. 2 plus 1 is 3. 0 plus 1 is a 1. Okay? The third thing I want you to do is end behavior. Look at the equation. Do I have a reflection? Everybody, yes or no? Look at this equation right here. Do I have any reflection in that equation? Please answer. Yes, I do. Okay? It doesn't matter if it's X or Y. Because if this is the original, then I know it's going to change. So my end behavior is left up and right down. Now I have every single thing that I need to graph this thing. Okay? So everybody watch. Go to 1, 1, put a dot, and label it A prime. Go to 0, 3, put a dot, and label it B prime. Go to negative 3, positive 1, put a dot, and label it C prime. My graph starts up, okay? By the way, this 1, 1 is not a turning point, okay? 2 seconds. Oh, got it. I'm good. This point right here, this is a turning point right here, and this is a turning point right there. The A, which is this guy right there, is not a turning point. Okay, now watch me do it. The left part's up. So it's going to be up, come down, hit it, and turn. Hit that guy, turn. Hit that guy, keep going, come down. I matched my end behavior because I was supposed to be down, and I'm done. That's it. This was on the midterm last semester, just so you know. Okay? Who says, I just want to see where we're at. First of all, if you're watching me, raise your hand all the way to the sky and keep it up. If you're understanding me, keep them up for a second. If you're understanding me, keep your hand in the air. Okay, yay. Okay, let's do this whole thing again. Here we go. What do you do first? X becomes, Y becomes. You guys, this is only the third time that I've taught this part of the lesson, and it's the best it's ever gone, just so you know. So I've got a good recording. I feel happy about it. Okay, do I have any changes to my X value? Yes, I do. X becomes X. Everybody tell me, what is it? Plus 3. Anything on the outside affects the Y. So Y becomes negative Y plus 2. You must write that down. Okay? Then write down the points that were on the original graph. So everybody go, A is negative 1, 0. B is 0, 2. And C is 3, 0. Keeping in mind that those last two are turning points. Okay? Now let's draw the arrows. And let's go A prime, B prime, C prime. Now let's change our x's. Take the x's and add 3. Negative 1 plus 3 is 2. 0 plus 3 is 3. 3 plus 3 is 6. Change the y's. Watch what people do. Watch. Don't write this down. There's a 0. Add it to 2, I get a 2. Change the sign, negative 2. It's wrong. Why is that wrong? Because I added and then multiplied, and I was supposed to multiply and then add, right? So this is like this. This is what you see in your head right now, guys. When you put in a 0, you see negative 0 plus 2. Well, everybody can see that that's 2 and not negative 2, right? So be careful. Okay, do the next one. You got your 2. Stick it in. That's negative 2 plus 2, which is a 0. Take this y, which is a 0, put it there. Negative y plus 2 is 2. Keeping in mind that this is a turning point and this is a turning point. You have to know the end behavior. Do I have a reflection? Everybody tell me, do we have a reflection? Yes or no, guys? Yes, yes we do. So the end behavior is no longer this guy. It's the opposite. Left up, right down. Okay? Now I've got all my pieces Now I just have to put everything together. So I go right 2, up 2, put a dot, label it A prime. Then I'm going to go 3, 0, put a dot, label it B prime, and I'm going to put a little T right there, remembering that that's a turning point. Then I'm going to go 6, 2, put a little dot, label it C prime. I'm going to remember that that's a turning point. I know that the left is up. So it's like this, guys. No turning point on the A. Left up, hit it and turn, hit it and turn, come down. I was supposed to end down. I'm good. Who says I got it? Let's see. Yay. All right. Now, let's see if we can skip some of these guys. This is literally the best this has ever gone for sure. You know, I'm just going to keep going. The reason I'm going to pick up my pace. I think we can pick it up, but I think it's so important that I'm not going to skip in. Okay? Okay, here we go. X becomes Y becomes. This guy right here affects the X. The X lies. So X is going to become X divided by 2. Take that yellow, replace it with a Y, 3Y minus 1. The original points on that graph were, tell me what page we're on, please. 21. 22. Okay. The original points on that graph are -1, 0 is A. B is 0, 2, and that's a turning point. And C is 3, 0, and that's a turning point. Now I'm going to change my points. A prime, B prime, C prime. Take the x's, divide by 2. That's -1/2, 0, and 3/2. Take the y's, multiply by 3, and then subtract 1. 0 times 3 is 3, 3 minus 1, -1. 2 times 3 is 6, 6 minus 1 is 5. You guys, let me show you something right here. Watch. Do you see how this y and this y are the same? Then this y and this y should also be the same because you're making the same change to it. Okay? Okay. Do I have any change in my end behavior of my original graph? Tell me that. No change. Why no change? No negatives. No reflections. So it's going to be like that. Okay? Okay, everybody go left 1/2, down 1, put a dot, label it A prime. 0, 5, put a dot, label it B prime. I'm going to put a little T there so I don't forget to turn. Where's 3 over 2? Where is that? 1.5. 1.5, -1, put a little dot, C prime. I'm going to put a T. You graph it. Graph it on your own. Okay, look at mine. Left is down. Come up, hit that guy and turn. Come down, hit that guy and turn. Come up. There's my graph. Who said I just did that fine? Raise your hand. Okay, I'm going to skip D. I think we're good to skip D. I'm going to come back to E. I want to get this. I want to do this right here. Okay, let's do 9. 9 is quick and easy. The graph of f of x minus 1 is f of x shifted to the left 1. True or false? You tell me. Is it left 1, everybody? No, because the x does what? The x lies. So it looks like it's left, but it's really right. So this is false. And underneath, I would write down right 1. Okay. This is what it looked like on the midterm. Right here. Okay. Let's fill in a couple of points. So this is -1, 0. And I'm even going to call that point A. This one I'm going to call point B, and that is 0, 4. And this one is point C, and that is 2, 0. Okay. Step 1, write down the changes. Can you imagine doing this problem without writing x becomes y becomes? That blows my mind. Like, why would you do that? That's your setup. So x becomes x minus 3. Y becomes 2y minus 1. Okay, write your points. Your points are -1, 0, 0, 4, and I want you to put a T by that letter B. And point C is 2, 0, and I want you to put a T because it's going to turn. Now change your points. So do A prime, B prime, C prime. Take each of those x values and subtract 3. So -1 minus 3, -4. 0 minus 3, -3. 2 minus 3, -1. Take the y's, multiply by 2, subtract 1. 2 times 0 is a 0, subtract 1 is a -1. So I know that's a -1 and that's a -1. The middle guy, 4 times 2 is 8, 8 minus 1 is 7. The end behavior of my parent is left down and right up. Do I have any change to my end behavior? Everybody tell me that. No change. The left is down and the right is up. Now it's just like a puzzle, like you're playing dot to dots or something. Okay, so everybody go left 4, down 1, label it A prime. -3, up 7. Put a dot, label it B prime, and put a T. -1, -1, put a dot, C prime, and put a T. The left side is down. So the left is down, comes up, hits that, turns, comes down, hits that, turns, ends up. Oh, supposed to end up. Done. Okay. One other question. Find g of -3. Everybody draw an arrow to that -3, and you tell me, is that an x value or a y value? It's always x. So what they're saying is, look at that graph, find an x value of -3, we're talking right there, and then finish the question. Don't answer the question, finish the question. What is y? Yep. On that graph, when x is a -3, what is y? -7. +7. Okay. I feel like we can stop. Do you feel like we can stop? Because it's hard, when I'm making this lesson up, it's hard for me to gauge how much you need. I feel like you're good. Do you feel good? Okay, I think we're good. These other things, you can figure them out. There's no special thing about it. Okay, that's it. You guys are awesome. Thanks for bearing with me.